Good morning, gentlemen. Welcome to this group discussion. First of all, let me introduce our speakers. Lucas Lu from GoodWe, and Mr. Lei Gao, product manager from Trinasolar, and Kevin Shu, product manager from TrinaTracker. Welcome. We all know in our PV industry, there are two main schemes for higher conversion efficiency and for lower BOS and LCOE of the PV system. We can say all of our participants of this industry work hard on these two targets. So on this snack show, I believe every one of you have new products, new technology, new solutions for our industry. Would you please give our audience some introduction from Lucas?
Okay, thank you, Wilson. Actually, this year we bring 3 new products to our all customers. The first one is the Android products, especially the HT series for the ground-mounted system. We have the new HT series. The capacity is 250 kilowatts, but the input current we can accept 20 amps. So that means we can compatible with the Trinasolar modules. And the second one is our commercial storage products. The capacity is 50 kilowatts. So this product is designed for the commercial storage. And if the customer wants to use a bigger water, we also can increase the capacity of the PTC to 100 kilowatts. The third one is our batteries. The battery is the first time to release to the customers. We have 2 batteries. One is the low voltage battery and another one is the high voltage battery. And these 2 batteries are fully compatible with our inverters. The name is the Lynx S and the Lynx U. So we have 2 new batteries. Thank you.
Lei?
Yeah, Trinasolar, we bring our full portfolio to Snake. Snake is the most important station in this year. So our product includes a 400 watt module, 500 mount module, 550, 60, 600 and 670 modules, which can be used for residential, C&I, and utility applications. And we also bring our edge cutting technology and cut the module current up to 700 watts, and another HJT product. The module power can up to 710 watts. Yeah.
Okay, that's impressive. Kevin.
So I think from the TrinaTracker side, in this snack, basically we have introduced our 2 main new products. One is we call Vanguard 2P, another is Agile 1P. As for Vanguard 1P is for the more challenging installation condition, and the Agile 1P is more fitable for the universal installation condition. But mostly importantly, both of these 2 products we are fully compatible with the logic to make module, also including Trina's 200 type big wafer module. So that's our this step.
We know Trinasolar launched a bigger size and with super high power PV module since 2020, and this year your power output for a single piece of module has grown to over 600 watts. So my next question is for Lei. Could you please give us explanation about the advantages of 210 module, and what is the meaning for the standard of a 210 module?
Okay, thank you for the question. Actually, we will more than call it vertex platform. Vertex platform means 210 wafer size, MBB technology, and high density interconnection technology. Okay, And with the 210 wafer, we developed 400 and 500 module, which have the best compatibility. Okay, so if you use it for the residential and for the C&I application, it compatible with all the inverters, all the mainstream inverters, includes our GoodWe inverters, and it compatible with all the mounting structures. So it's very welcomed in many countries, especially in Europe. Okay, another we can see another brother in the Vertex family is a low voltage, high stream power module, which designed especially for the utility. It's high, as you just said, it's high power modules. The module power output up to 600 plus. Okay, and in the past we made a lot of case studies, and we found that in the past includes 158, 166. Each company have different size of the modules, so it will generate some complexity for their customers. They have to adapt to different inverters, different tracker, different mounting structures. So it's complicated somehow. And when we developed the Vertex, we talked with many modules manufacturers like CSI and some others. Okay, and the Ryzen, so we come together with the wafer and the silicon suppliers, and we found that we have to finalize something to let our customers life easier.
Yeah.
That's why we developed such kind of standardized work. And as you just mentioned, in the end of last month, the international silicon electric institution already recognized our standard for the 210 wafer and for the 210 wafer size module.
Yeah. Can I conclude like this? The 210 module can significantly improve not only the power point, but the power output, but also the conversion efficiency. And the standard of a 210 module will reduce the cooperation efficiency here in the industry chain.
Definitely, as I just said, the Vertex is a platform, right? And the 210, based on 210 wafers, we can develop the edge parting N-type technologies, includes N-top, and the HGT. Yeah. So both of them can improve on the efficiency. Okay. From the cost efficiency part, based on our design concept, the low current and the high stream power, so it will significantly reduce the cost of the cabling and the tracker, and also on the system side.
So I think the utilization of the bigger size module, like a 210 module, must have new requirements and technical requirements to either tracker and also the inverter. Can you give us some issues?
Yeah, based on our design concept, the low voltage, high stream power, which will generate a higher current compared with the conventional modules. So we have to compatible inverter working with our 210 module. And meanwhile, we have a larger size than the conventional module, which can save a lot of labor cost for the installation. But somehow it will impact a little bit on the tracker side. That's my opinion. So we have Lucas and we have Kevin, and we work together, and we work with some other manufacturers like the silicon and equipment, and we get lines, the 600 plus lines. Yeah. So.
Yeah. So Lucas, how does the GoodWe respond to the new features of the 210 module?
Yeah, actually, the 210 size modules is a big challenge for us in the past, but now it definitely isn't no problem for us because we already have the new product compatible with the 210 modules. Just Lei already said, they also have the modules only for the dispute application scenario, like it's 400 watts.
Yeah.
So the current from these two modules is only 12 amps. So last year we already have the products already compatible with these modules, and this year we still increase the input current of the inverter. So the new products of the GoodWe like DNS series, SDT-G2 series, and the SMT series, the input current will already reach up to 50 amps. So these inverters already compatible with Vortex 400 watts and 500 watts. So for the distributed scenario, it's totally no problem with our inverters. And also, they said they also have the modules for the utility scale projects. It's 550 kilowatt and 6. So it's 550 watts and 600 watts and 670 watts.
670.
Okay. So this module's current will be more than 80 amps if we consider about the backside of the module. So for these modules, actually it's a big challenge for GoodWe, and also I think it's also for another water manufacturers. So that's why, just I already mentioned, this year we also released the new products, HT series, only designed for the 210 size of the modules. So for HT series, 200 for GoodWe is 250 kilowatts. So we can support 20 amps each string to connect the modules of the Trinasolar.
Okay, I think GoodWe has made a preparation very well. So, Kevin, how do you think your tracker system?
Yeah, I think from the technology point of view, the Vortex module, the big format module for trackers, one side is channel. Okay, so anyway, the modules, so like the length, width, and even the weight, all they change. So this will have the impact for the tracker design. Just for the modules width, for example, it will make the track much longer than before.
Yeah.
So that will lead to the trackers much higher torsion than before. So it's what I call just for example for the challenge. But I think at the same time it's also an opportunity because of this challenge. So under all the large format module background, I think all the tracker supplier, they need to redesign the tracker system according to the latest the model. And this design, we need to work study with the like the wind engineering and the new mechanical calculation. So that's not easy for everyone. So I think the Taiwan company, the excellent company, who focus on paying more attention to the research and engineering, will pick like opportunity to make this product reliable and compatible with Vortex model, just like the Trinasolar. Just I mentioned our Vortex Vanguard tracker and the TrinaTracker. This research and engineering analysis, we can see we are compatible with large format model. So that's difficult, but now we are happy we have overcome all these difficulties and totally compatible with large format, including Vortex model. Yes.
Yeah, difficult, but having solved. Well, my next question is for Kevin and Lucas, because we know in a PV system, the interactivity and intercommunication between the tracker and the inverter is very important and also be helpful for the entire working efficiency. So how do you work closely? How do you cooperate with each other?
From my side, I think we need to work closer with each other, especially on PPC and platform. Like I think in the future we can share the data with each other in one platform. Just imagine for the maintenance people, if they have like too many platforms to do their job, like maybe they have the SCADA system, they also have the water monitoring platform, the tracker platform, also maybe they have another platform. So too many platforms, it's too complicated for them, too difficult for them. So I think if we can integrate all the devices information to one platform, like the water can send that to the communication boards, to the PPC, and to the platform, and also the tracker system also can do so this way to the same platform. So, for example, if the modules need to be clean, so the platform can send the command to the tracker, and also can send this command to the water at the same time. And also, like if the water has a problem, the water can send the data to the tracker. So the tracker don't need to find the best angle. So, and also maybe the inverter already overload. So the inverter also can send the information to the tracker system. So the tracker system also don't need to find the best angle. So that's my idea. So maybe in the future, we need to find the best way to cooperate with each other. We need to integrate with each other.
Yeah, thank you, Lucas. That's a view from the inverter side. So what is your view?
Yeah, I totally agree with just Lucas said. So I think for the downstream corporation like inverter to tracker, just for example, currently now I think the first step which we are doing now is for the we are doing the compatibility job, like from the tracker compatibility with inverter, module compatibility with tracker. This is first step, but I think the second step. We are looking forward for the future, the big look for the integration and cooperation, just like Lucas just said. I think for tracker and the inverter, we have something in common. It's like the electrical control parts. We all have. I think I think inverter maybe 80%, but for tracker maybe now it's 70%. But I think in future, electrical control parts for tracker we are increasing. Like 40, even 50, will be more and important. Both of us, we have the electrical control parts, just like you said. We have the monitoring, controlling, and the data hub collection, and how to detect the issues and do the optimization. I think what I can see now, definitely we have the overlap. Even in the tracker, we also have the communication. But I think the inverter also have. We have the data connection. Inverter also have. But I think from the technological view, for this overlap, we have to learn through integration and optimization. So under this integration and optimization, if it happens, I think it will happen. So we can reduce the system cost together. So I think that's the reason why we are sitting together today for future cost down and improve the whole PV systems competitiveness. So I'm very happy with that and looking forward to that.
Yeah, I also agree with that.
And Vincent, I saw a lot of more possibility if we standardized.
Yes, the standard is a very important issue for the industry chain to improve the efficiency and reduce the cost.
Yeah, cost.
Yeah. So that's a very good discussion, and we shared our audience and the industry how to use new technology and new products and even new method to improve the compatibility of the PV solar PV. So thank you all.
Thank you very much.
Thank you.
Thank you, Vincent.
Thank you.
Thank you. Yeah.
That's
Okay.